Welcome to today's lesson. This is for Thursday, 9/17, and we are going to be looking at factoring GCFs and special factors. Now, the first concept is factoring out a greatest common factor. Greatest common factor, if you don't know already, is the largest factor that each number shares. And for variables, it is the largest number of x's that each shares, which is usually the smallest exponent. So in this first example, this doesn't look like anything I can factor based off our lesson yesterday. However, when I look at 18, 42, and 120, they each share a 6, a factor of 6. That's the highest one that they share. They also share a 3, but that doesn't help us because we want the largest one. And I look at it, they each also have 2 x's. The lowest exponent 2 would indicate that. This also has 2 x's. It actually has 3. This also can share 2 x's because it has 4. So the first thing we're going to do is take out our GCF of 6x squared. And when I say divide out the GCF, if you don't know already, that means to divide each term by 6x squared. 18 divided by 6 is 3. X to the fourth, take out 2 x's, leaves you with 2 x's. Negative 42 divided by 6 is negative 7. I have 3 x's. And if I take 2 of them out, I'm left with 1. Negative 120 divided by 6 is negative 20. And take the 2 x's out, there's no x's left. And so I'm left with this in parentheses. But often you will have to factor what's left inside, and we're going to practice that. Now, not always. Sometimes it's just a GCF, and what's left inside doesn't factor any further, and the problem is done. However, on this one, and on many of the ones I'm going to give you today, what's left over inside the parentheses will need factored again. So using yesterday's lesson, I break 3x squared up into 3 and x, and I break 20 up into 5 and 4. The outside gives me 12, the inside gives me 5, makes negative 7. And then this would be the final answer. Notice the GCF is still in the answer. It's not just the 2 parentheses, it's the GCF and the 2 parentheses that make up the final answer. Okay, so let's take a look then at the next concept called conjugates. This is really the easiest factoring problems you'll come across. A conjugate in Algebra 2, unlike in English class, is 2 binomials that match except they have opposite signs. So x plus 7 and x minus 7 are conjugates. Now watch what happens when I multiply conjugates together. When I distribute, I would get x squared minus 9x and 9x minus 81 when you multiply that out. And look what happens in the middle. The middle terms cancel, leaving me with just x squared minus 81. When you are multiplying conjugates, the middle terms will always cancel. Always. So when you see this and you recognize, oh, those are conjugates, you don't even have to multiply the middle. X squared minus 81. You can skip the outer and inner because you know those middle terms are going to cancel. Okay, that's crucial for a lot of stuff that we're going to do this year and in future math classes. Okay, conjugates, middle terms cancel. Well, then how do I factor with something like that? Well, when I see a problem like x squared minus 64, I recognize there's no middle term. This has to be a conjugate situation, most likely. So I'm going to factor this into x and x. Factors of 64 are 8 and negative 8. Look, there's your conjugates. The 8 and negative 8 will cancel the middle term out. And so I get x plus 8, x minus 8. Notice the square root of 64 is 8. Square roots are going to play a role in these. So we do have a formula to summarize the conjugate rule, that if I have 2 things being subtracted, they have to be subtracted. If that's a plus, it doesn't work. A squared minus b squared. The square root of those would give me the numbers for the conjugates. A plus b, a minus b. A plus b, a minus b. A couple more examples just to demonstrate this formula. I see x squared minus 144. Square root of 144 is 12, so the answer is x plus 12, x minus 12. And I can use the conjugate rule because I know there's no middle term. This is going to cancel. How about this one? I have a 9 and a 121. Oh, those are perfect squares. 3x and 11. The square root of 9 is 3. The square root of 121 is 11. So 3x plus 11, 3x minus 11. And because they're conjugates, I know the middle terms are going to cancel. Again, another one, no middle term. 25 and 1, 5x plus 1, 5x minus 1, because the square root of 25 is 5, square root of 1 is 1. So these should go very quick and simple. If I see 36x squared minus 25, oh, 36 square root of 6, square root of 25 is 5. 6x plus 5, 6x minus 5. Done. You could have a GCF with one of these, like if I had 10x squared minus, I don't know, let's just say 40. They both share a 10, and then when you take the 10 out, oh look, it's a conjugate problem. X plus 2, x minus 2. So that GCF first could take place with these as well. Okay, and you'll see some of those at the end of the homework. Alright, let's wrap it up with the last one. The last type of special factoring is perfect square trinomials. The key to a perfect square trinomial is that you use the same number twice, because they will both add to make the middle term and multiply to make the last term. If you want to write that sentence down, pause and do that, and then press play again. So when I look at this example, what number twice would add up to this and multiply to make this? And I'm thinking of the number 7. So if I had the number 7 twice, 7 plus 7 makes 14, 7 times 7 makes 49. But when we do perfect square trinomials, we are getting the same parentheses twice. So it's this parentheses times itself. So we write our final answers as x plus 7, the quantity squared. This factors into x plus 7, the quantity squared, because 7 gets used. 7 plus 7 makes 14. 7 times 7 makes 49. Let's explore that just a tad bit more, and then we'll be done. Okay, so this is just the same thing I wrote again. The formula for this, if you see something that has perfect squares at the beginning and end, like x squared and 49, those are perfect squares. 2ab has to fit in the middle. We'll talk about that in a moment. Your final answer must look like this. So when I look at this, x squared and 16, those are perfect squares. X plus 4, because 4 plus 4 makes 8, 4 times 4 makes 16. So the answer is x plus 4, the quantity squared. How about this one? X 12. Notice the minus sign though, so it needs to be x minus 12, the quantity squared. And doesn't that work? 12 plus 12 is 24. 12 times 12 is 144. How about a number in front of x squared? 4. Okay, the square root of 4 is 2. The square root of 81 is 9. And again, notice the minus sign this time. So it's 2x minus 9 squared. Does that fit the formula? I think so, because the square root of 4 is 2. Okay, 2 times 2 is 4. 9 times 9 is 81. But that's where this 2ab comes into play. Because if I have 9 and 2 as my two numbers, multiply those together, make 18. But it's double that. Just like back here, we doubled 4. 4 times 2 is 8. 12 times 2 is 24. So when you double 18, it gives me 36. Yeah, that fits that middle term. Let's do another one real quick. 196 is 14. 9 is 3 when you take the square root. So 14x plus 3 squared fits these two. Does it fit 84? Well, let's think about it. I have 14 and 3. That would make 42. And when I double it, so I take 42 twice, it gives me 84. So I know that it works. Okay? You can go ahead and start the homework now.